what happen will be rotated for optically active. For optically inactive, what happen? The plane of polarization will not be rotated. There's the meaning. So possibility of asking, we don't know because we don't have any limits, no, exactly. In NCERT book, nothing given, but we don't have any strict condition that they may not ask. Or what is optically inactive means? Which it does not rotate the plane of polarization, polarized light. I think, can you remember, we had a plane of vibration, plane of polarization. So that plane of polarization should not be rotated. Some materials are there which will rotate. They are called as the chiral materials. Chiral. Achiral means which will not rotate. Maybe in chemistry, in organic, you may come across chiral, achiral. Where do we use chiral, achiral? I think in the fighter planes, because the two, suppose say like a squadron, one squadron contains some 10 planes, fighter planes, or five. One squadron contains, like if in a group you can say 5 planes. They should communicate with each other, no, to attack an enemy. When they're communicating, what happens? That signals, what happens, should not be intercepted by other person. Therefore, what happens? We will rotate this plane of polarization, and how it is rotated only we know. The opposite enemy will never come to know. There, what happens? We use chiral materials. Okay, let's not bother. So just this optically inactive word can be introduced even in polarization. That's why I just brought here. No, a linearly polarized electromagnetic wave. It is propagating along z-axis, you can see. And E bar is along x-axis. Is incident normally on a perfectly reflected infrared at z equal to a. Assuming. So z, what happens, should become negative, no? Z, you are going to make it as minus z. Go back to the transverse wave. If it changes direction of motion, you are going to write minus z. This is the incident wave. Reflected will be minus z. I'll better let me write equation. It will be easy for you. E naught cos. This is incident wave. For reflected wave, what you are going to do? Justified, the value of z has to become minus minus z, no? So this will be the why can't be this, sir? Negative sign. Because there's nothing wrong in these two, no? These two are ruled out. But sir, will it be inverted? Phase change of pi radian. So I think that we have to go for reflection at a conducting surface. What will happen? All other things. So let's not bother. Perfectly reflecting infinite wall is telling. Incident normally. Reflection at a free end or something. So for EM wave, okay, you can just put only change the direction of z and conclude here. The same idea, what we discussed for transverse, same thing. If it is reflected by rigid end, plus pi you should bring. Reflected by free end, no phase change.
What we should take, sir?
Wall will be rigid end. Huh?
So phase change of pi should we take on?
Okay, pi will come. Okay, I'll introduce pi better. Yeah. Wall is telling, no? This is. Plus pi, no? How much will get in this one?
Minus will get outside.
Minus will get outside. Huh? Kz cos of anything minus theta plus phi, or cos of theta plus phi, how much will be?
minus cos theta.
Minus cos theta. Okay, this one. And minus of cos of minus theta will be, well, I'll do one thing. We'll simplify stepwise. It will be
Sir,
yeah.
light waves are transverse now. They are independent of the medium. So if it is a rigid end or a free end.
Whose side? Nothing like that. Nothing like that. It's what all we discussed in the transverse wave applicable for all waves, sir. The wave moves from rare to denser, denser to rarer. It all depends upon the phase change. Perfectly Stellinger. Oh, what happened? Now let's, I think we are here. Okay, let me, I think many are asking doubt. Let me clarify it. Now, see what all we had the discussion in the transfer. So here also, if the light moves from rare to denser, so I'll make things clear. This one, if this is the, if I say mu2 greater than mu1, what does it mean by this one? This will become denser. Now v equal to c by mu2. So v2 will be less than v1, speed of light. Where it is less, it should be denser. Even power not there. Okay, we'll just finish off this one. Okay, I'll do one thing. Reflected wave, reflected by a denser medium. So you mean to say perfect? I think it is something perfectly rarer medium or transparent medium. Something you should have mentioned further here. Reflecting infinite wall. Wall means it should be rigid. So I think answer will change it. I thought of optically wall. The metal of the wall is optically inactive.
What happens if it is optically active, sir?
Optically, the plane of polarization, it will also change. Nothing. This is only for polarization. This is only for polarization. Optically active, inactive is only for polarization. Nothing to do with reflection.
Okay,
I think so let me clarify, because I thought like it's something reflected by rarer medium. If the wall is telling that the material of the wall is optically active, himself is telling that's material. The material what happened compared to where it is The wall can be like a denser or rarer, no? It all depends upon condition.